Okay, so remember for converting, let's say that, let's say that I give you a point, and it's at 4 root 2 comma negative 4 root 2. And this is x and this is y. Do you know how to convert it to r and theta? Do you know how to get the polar representation? Right? Okay. So how do we find r? I'll just call on people. So how do we find r, Jeannie? Right. So that would mean that this is the square root of 4 root 2 squared plus negative 4 root 2 squared, which really is just 32 plus 32. So this is just square root of 64. It's 8. 8. How do we find theta? How do we find theta, Justin? Yeah, it's inverse tan of y over x. That's right. So inverse tan of y over x. Do we add, or I should say, when do we add the 180? Yeah, when x is negative, but that's not what's happening here, is it? X is not negative. So this is just tan inverse of negative 1. Can you think of an angle whose tangent is negative 1? Blake? .45 would be positive 1.
Yeah.
It's true, 135. 135, also 315 has that same property. So we have to choose one. See, a point cannot have two angle representations. So which one is correct? Is it the 135 or the 315? It's actually the 315, and the reason is this point is clearly a positive negative. It's definitely down here in quadrant 4, isn't it? So there's no way it could be 135. 315 it is, right? Okay. So that's just converting x, y into r theta. How do you do that in reverse? Let's say I gave you r theta and asked you to convert to x, y. And I don't know, let's go with 5 comma 5 root 3. And just for kicks, let's put some negatives in there. Okay, so how do we convert r and theta into x? So what's the formula for that, Kathy?
X is r equals cosine theta.
Oh, I'm sorry, my theta doesn't make any sense. I should have put a 4 pi over 3 here or something. Let me make that an angle, sorry guys. This is the angle 4 pi over 3. So you said x is r cosine theta?
Yeah.
You're right. Negative 5 cosine 4 pi over 3, which is really negative 5 times negative half. Or you could say 5 halves. Yeah, good. How do you find y? Go ahead, Kathy. How do you find y?
Y equals, y equals r sine theta.
Right. So negative 5 sine 4 pi over 3. And there is an assumption that you know your unit circle. You're not actually allowed to use your unit circle on Thursday. I will let you make a note card, but no unit circle. Okay? So this is 5 root 3 over 2. No note card, no examples, no unit circle. No identities. It's just formulas that you need. Okay. Anyway, that means, 2.5 and then 2.5 times rad 7. So rad 1.7. Anyway, you can plot it out and you can see this makes sense. So you might say, well, how can this problem be a quadrant 1 problem? So let's talk about that for a second. So remember, you were given a polar representation. Those are supposed to be circles. Okay? Where is 4 pi over 3? Can you point to that with your pencil? Which direction is 4 pi over 3? Isn't that over here? What does it mean to have an r value of -5? That means go against this arrow, right? Go backwards from this arrow. So you're going to go 1, 2, 3, 4, 5. So you're actually up here. This is the point because it's a reverse direction 5, see? So it really is a quadrant 1 point, just like we got a positive and a positive one here, or a positive on x and y there. So it makes sense, actually. But you should always check with your common sense. All right, let's try converting equations. So what if I give you an equation like r squared minus 4 equals 0, convert to rectangular. That means get rid of the r. I want x's and y's. So what do you think should we do? What should we do with that one, Robin?
Substitute radical of x squared plus y squared for y.
Okay, r is just square root of x squared plus y squared. Yeah, that's true. So what happens here? You end up with x squared plus y squared minus 4 equals 0. Move the 4 maybe. How do you know when to stop with this kind of simplifying? Well, once it looks familiar to you, you can stop. So for example, this now looks like the equation of a circle from the geometry days. Or if you're not comfortable with this and you don't recognize it, you can divide by 4. What is that thing? Yeah, it's an ellipse with the same a and b, right? So yeah, now you realize, oh, that's a circle, I get it. Standard form. So find a standard form to write it in. I don't usually make students go all the way to this. You can do that if you want, but nobody really likes having the plus and minus there. And it's kind of hard to tell what that is. That's 2 semicircles. Okay? So you can just stop when you reach a standard form you're familiar with. Let's try this one. Actually, I want to make the right side a 10. Sorry. R cosecant theta is 10. All right, any suggestions on this one, Brittany?
Convert cosecant to 1 over sine.
Okay, convert this to 1 over sine. That's a good idea. What might we try next, Jen? Change the r to square root of x squared plus y squared? We could do that. I think what's going to happen is if you try to jump into x's and y's right now, you're going to have a little trouble replacing the sine theta. So let me show you what I mean. You only have certain formulas to work with, right? So you have basically x is r cosine theta, y is r sine theta, right? R squared is x squared plus y squared. R is the square root of x squared plus y squared. And then tan theta is y over x. Like, you don't have that many rules here to work with. So if you try to switch r right now to square root of x squared plus y squared, what are you planning to do with the sine? See the problem? So I don't think we're quite ready to do any substituting yet. Any other suggestions? What do you think, Andrew?
You could multiply both sides by sine squared, and then like,
Multiply by sine?
or,
You said sine squared?
yeah. Because then like you could get r sine theta. And
Oh,
then
okay.
You just get y. Sine squared.
Okay, so you said sine squared. Did you mean r squared?
Yes.
What are you trying to get on the right side?
Try to get r sine theta on the left, so you can replace that with y, but then you have a sine squared on the other side, so it's
Yeah, I don't think we can multiply by sine squared. We don't have a sine squared here. We multiply by sine, but we're still kind of stuck. Yeah.
You can make r squared over r, and then so the r is sine theta on the denominator.
Okay. So you could try rewriting r as r squared over r. How about multiply both sides by r? This is an old trick I taught you back when we were doing this the first time. I suggest occasionally multiplying both sides by r. So what does this accomplish? This makes your life a lot easier. Okay, first of all, the left side is now r squared. The right side is 10r sine. See? This is so much easier to work with. The left side is easier to replace now, isn't it? Look at the green. What's the left side? Look at the green formulas, guys. What's the left side? Class response. X squared plus y squared. 10r sine theta. What's that? That's just 10y. You're done. Well, you could bring everything to one side and show it's a circle again. So you could just bring the, bring the 10y over, like that. And then you can add a magic 9 to both sides, magic 25 to both sides. Okay, so this factors beautifully. Look at this. X squared plus y minus 5 squared equals 25. This is a circle with center at 0, 5. Radius is 5. Or maybe you took the time to memorize some basic facts back in the day. Remember when we were doing polar equations? Maybe you recognize this. Some of you recognize this right away. You're like, oh, I know that one. That's just a circle with a diameter 10. You made some flashcards, remember? Done. And you know it's on the y-axis because of the sine. Cosine would be on the x-axis. So maybe you could jump straight from there to there and then realize that this is the equation. See? So that's for the student who tends to memorize more. They'd be like, oh, I know that. That's the circle, diameter 10, and it's resting on the y-axis because it says sine here. When it's cosine, it's over here. Okay, but that assumes you've been reviewing your flashcards, right? Or we can just do that. So what's the key trick on that one? Multiply both sides by r. That's a great thing to do. Okay. How do you take an equation that's in rectangular and work it back to polar? You know what I'm saying? How do you do this in reverse? So let's try some of those. Let's say I just give you r equals 4. This is an easy one. Remember, you only have these for your choices. X is r cosine, y is r sine. R squared is x squared plus y squared. R is the square root of x squared plus y squared. And tan theta is y over x. This is your little tool bag. What might you want to try? What do you think, Cecilia?
Think that R,
We're going to try to get rid of r and make it into x's and y's.
because R is square root of X squared plus Y squared.
Oh, I was actually trying to do one in reverse. So this is just another example, I'm sorry, of what we were doing a minute ago. Okay. Is this something that you recognize? Maybe not yet. What might you want to try next? Okay. X squared plus y squared is 16. Do you recognize this yet?
It's a circle.
It's a circle. Yeah. Maybe you haven't learned circles in a while. I didn't really teach them. But you can also just divide both sides by 16 and say, oh yeah, it's an ellipse. A and B are the same. Well, that'd be a circle. Okay, so it's a circle. Stop when you realize what it is. Okay, good. Let's try a problem where you have to get it from x, y into r. Okay, this one looks harmless enough. X plus y equals 3. Now you don't want x anymore. You want r's and thetas and such. So what do you think we should do, Mario? Okay, most people wouldn't really recognize this. Like they look at that and they'd be like, I don't know what that is. Okay, so normally we just try to isolate R if we can. It's not always possible, but let's try it. How would you get R by itself? What do you think, Ume? Yeah, factoring is a great way to separate. And then how would you get R by itself? Go ahead, Ume.
Divide by R.
Divide by what?
Cos theta
Cos theta
plus sine theta.
plus sine theta. Right. So you've got R by itself. Maybe you don't know. Maybe you can't look at that and say, oh yeah, that's a line. But, you know, you could graph it on your calculator screen. Just put your calculator in polar mode, you know. You got R by itself, so that's half the battle. Some people can look at that and say, oh, that's a line. But I don't know how important that skill is. Okay, what about this one? X squared, or let's do xy equals 1. That's a cool one. Xy equals 1. So, what do you think, Peter? What should we do? Right? What might be a good second step? Yeah, sorry, Peter. Divide by R? Well, we probably want to have R by itself. Yeah. So you have R squared here. And you can divide by the cosine and the sine simultaneously. So, yeah. And we can square root both sides if we want to, but it's kind of a tradition to just leave it as R squared equals. Okay, good. All right, let's do, how about if I gave you theta equals rad 3, and I said put into rectangular form. How'd you do that? We don't really have a formula for theta, do we?
What about the tan inverse?
Okay, so this formula here on the right can be manipulated to read tan inverse y over x. It's true. You can always take identity rules and manipulate them before using them. We did this actually with our identity sheet. Remember we had an identity sheet? We manipulated some of those before using them. You can manipulate any of these, they are facts. They're equations. So how would we maybe work on this problem? And you want to finish that idea then, Blake? Because you started that off? Wait, who suggested that? I'm sorry. Never mind, it's Andrew. Go ahead, Andrew. So what do we do?
Okay, so multiply both sides by tan.
Okay, so multiply both sides by tan. We could do that, okay? So the left side is y over x. The right side is just pi over 3. Pi over 3 is 60 degrees. 60 degrees is the tangent. I mean, what have I done? Why did I write rad 3 here? I meant to write pi over 3 here. I mixed this up. I always do this. Sorry. The problem was supposed to read theta equals pi over 3. Sorry. And then Andrew's suggesting we put a tan on both sides. So now this reads y over x equals rad 3. Sorry about that. Sorry about that. The formula, or the equation now in rectangular form, do you recognize it? What is that thing? It is actually a line. If you multiply both sides by x, it's kind of obvious. It's a line. It has a slope of rad 3. So it has a 0 y-intercept, and it has a slope of rad 3. Well, no wonder it's called the pi over 3, the theta equals pi over 3 line. Right? If you put polar grid on here, you can see that all of these points have the same theta. So that makes sense. Okay, so putting a tan on both sides, multiplying both sides by r, stuff like that, which we did. The textbook is loaded with examples of this. You can find them back in chapter 8. Just go through your review if you need. Let's talk about, for our last 5 minutes, let's talk about I a little bit. Okay? So a lot of the formulas are the same, but some of the vocabulary changed. So like if I said, what is 3 plus 3 root 3I? What does that mean? Well, this is a complex number, not a vector. But you can kind of visualize it. You can think of it as a vector, kind of. It's kind of like the A and the B for a vector, you know. It's almost the same idea. But anyway, 3 and 3 times 1.7. So you could actually plot this point on the complex plane graphing paper. So this is like x and this is I, y. You might remember doing this. You can even measure the distance from here to here using the Pythagorean theorem. So you could just do square root of 3 squared plus 3 root 3 squared, which is just 9 plus 27. Anyway, this just comes out to 6 right here. But we don't call it magnitude, we call it modulus. It's just like the same thing as magnitude. So basically that's the modulus. And you can also find this angle right here. It's actually not called angle, it's called argument. But you can certainly use inverse tan of the imaginary number over the real. And what is that angle? That's 60 degrees. So what we're saying is the complex number 3 plus 3 root 3I is identical to six cosine 60 plus I sine 60, or as we abbreviated in this classroom, I don't know if Mr. Lynch did this or not, we just wrote it as 6 cis 60. We kind of stole the C, the I, and the S from cosine plus I sine. And we sort of abbreviated, if you remember. So 6 cis 60 is a nice abbreviation for the polar format. 3 plus 3 root 3I. Okay? So let's say you had to, let's say you're given 3 plus 3 root 3I and negative root 2 plus root 2I, and you were asked to multiply these. You can FOIL them if you want to, or you can switch them to polar form. This one we already did. It's 6 cis 60. This one I got to work on for a second. This just comes out to 2 plus 2 is 4. So this just basically comes out to 2. And the angle is tan inverse negative 1. Blake already told us earlier that that was 315. Oh, sorry. Yeah, our x is negative. So it's basically negative 45, and you're adding the 180. Can't forget to add that 180. So it's negative 45 plus 180. Yeah, it's 135 actually. Okay, so this is 2 cis 135. So I switched it over to polar form. You might say, that's a lot of work, Mr. Shore. I'd rather just FOIL them. Well, the cool thing about polar form is once it's in polar form, it's so easy to multiply them. So how do we multiply these again? Do you guys remember? Modulus times modulus what? Argument plus argument. Very cool. The answer is 12 cis 195. That's a really cool way to multiply complex numbers. Or if I say, what's 3 plus 3 root 3i over negative root 2 plus root 2i? Back in Algebra 1 days, or maybe Algebra 2 days, you would have had to use a conjugate to solve this. And your answer's pretty messy. Watch how we can do it with polar. This we already said was 6 cis 60. And this is 2 cis 135. So what do we do with our moduli and our arguments? We divide the moduli, but we subtract the arguments. And we don't usually use negative arguments, so we should just add a 360 here for good measure. No pun intended. 3 cis 285 is a better looking answer. And some people say, well, that's just totally optional. You don't have to use polar. Well, when you do like 3 plus 3 root 3 to the 50th power, you're going to want polar, not rectangular. So we'll talk more about Demoivre's theorem tomorrow. I will send you an assignment, okay? So make sure you bring your books home tonight. Very important.